Okay, we're recording. So today what we're going to talk about is really line segments or chords. Line segments in circles, okay? Line segments in circles. And today's date is 5/30, almost June, yay. So, first example is old stuff, okay, and it's a nice little review of what we just kind of did on our warm-up, but I wanted to do it again because the very first test question you're going to have on Friday is a problem like this, and there's so many places to make a mistake. And the problem with this particular problem is if you make one little mistake somewhere, it just makes everything else wrong, right? So let's go through it and see how we can do this and do this right, okay? So when I take a look at this figure, I'm looking at, okay, what do I know? Well, I'm going to start right here at the 20, okay? And I know that that 20 is an inscribed angle, which makes it half of its arc. So the arc here has to be 40. So I'm going to just put a 40 right there, okay? I know the same thing here. If this arc is 60, right, then if this is arc 60, then its inscribed angle has to be half of that. So this angle is 30, okay? Let's pull a Claire move, because Claire had a pretty clever move. Claire said, you know, in a triangle, in fact, I'll call it a Claire move. I like to Claire. It's actually clever, very clever. But if I take a look, I'll try and highlight this for you. I think I've got a triangle. See the triangle I've got here? You guys see the triangle I've got? And we all know that in any triangle, it's 180 degrees, right? So I've got my 100 plus 50 makes 150. So this angle's got to be 30. You guys okay with that? Because you see the triangle, right? I can even get this angle here, angle F, right? Because I can see, well, a triangle here, that makes 50, so this angle F's got to be 130. Can you squeeze that 130 in there from a triangle? Then, if I've got 130, I can get this triangle right here. Okay, I just keep working on my triangles. You guys see the triangle right there? So that's 130, which makes this angle 50 there. And that's kind of handy. I like that. If that angle's 50, because I got a triangle right there. You guys see my triangle? That's kind of handy because if that's 50, and that's an inscribed angle, and this arc's got to be twice that. That makes that arc 100, right? And then I can get this arc way up here because I can get from 360 degrees. I can take 360, and I can subtract all these other arcs. I can subtract out my, let's use my calculator. How many degrees does that go all the way around? Okay, hold on. I'm going to go my 40 plus my 60 plus my 40 plus my 100, and I get 240 minus my 240 makes that 120 there, right? And I think I have just about everything. 100, 100 here, 80, and 80. Okay. So again, can you do that problem or one just like it on Friday? Say yes, Mr. Davis, I can do it, right? Okay. Yes, Mr. Davis. Good, I like it. So I think the big key is to find triangles. Would you guys agree with that? Start finding your triangles. You know, every triangle's got 180 degrees in it, and just work from there. And remember that inscribed angles are always half their arc, okay? All right, slide it to example 2. Example 2 is what we learned today. We learned that this piece times this piece equals this piece times this piece, right? So I'm just going to go 6 times 4 is equal to 8 times x. I'm just going to go this times this. So we'll go, all right, I go 6 times 4 equals 8 times x. This piece times this piece is equal to this piece times this piece. So I get a 24 equals an 8x, right? Divide by 3, and x is equal to 3. Thumbs up? Okay, good. All right. All right, so am I going too fast? Am I doing okay? Okay, let's slide it over, okay? Now this one, let's go back to our notes, and I said, well, it's the piece on the outside times the entire thing equals the piece on the outside times the entire thing. So I'm going to go, all right, I'm going to say, all right, 4 times 4 plus 6. Okay, that's the piece on the outside times the entire thing, okay? 4 times 4 plus 6 equals 5, that's the piece on the outside, times 5 plus x, okay? So we got this times 5 plus x makes the entire thing. Okay, and then I just have to solve for x. That shouldn't be too bad. Okay, to solve for x, I'm going to have 4 times a 10, right? Because 4 plus 6, I can do that. And here I'm going to have to distribute. I got to do a little bit of algebra. 25 plus 5x, right? I'm going to have a 40 equals a 25 plus a 5x. How am I doing? Okay. Not going too fast. Minus 25, minus 25, what's that, 15, I think? Right, divide by 5, x equals 3. Okay, thumbs up. Good. Example 4, am I going too fast? Am I good? Slow me down if I get going too fast, all right? So example 4, all right, it's this one. It's this thing, it's like this squared because it's the piece times itself and equals the piece on the outside times the entire thing. So I'm just going to go, okay, I'm going to say x squared is equal to my 4 times my 4 plus my 5, okay? It's the x times x equals 4 times the entire thing, the piece on the outside, okay? So x squared is equal to 4 times 9, right? Just added 4 and 5. 4 times 9 is 36, right? So that x is equal to 6. And you guys can definitely do this on Friday, right? Especially with your notes. You're good if you have your notes, right? Okay, ready to turn the page? Turn the page. All right, now, looks kind of complicated, but it's not. So what we have to do is this. Let's look at this problem as 2 different problems. If I kind of hide that, see I'm hiding that? It's gone. We can get x pretty easily, can't we? Right? Should we get x? So if I hide that part, you guys see what I got? I hide that part, so we're going to go, all right, we're going to take that times that equals that times that, right? Or 3.2 times 10 equals 4 times x. So let's figure out what x is first, and then after we figure out what x is, then we'll go and get y. So we get 32 equals 4x, right? And that should be 8, right? Divide by 4, divide by 4, x is 8. How am I doing, okay? Now, what I'm going to do is actually put the 8 in. So if I know x is 8, I'm going to change that to an 8. So I can go for y. Okay. So we learned that we can go y times y. Y times y equals the piece on the outside times the entire thing. So, okay, y times y, or y squared, equals, all right, 6 times the whole thing. So the whole thing is really 6 plus 8 plus 40, okay? Does that make sense? It's a piece on the outside times the entire thing, okay? So the entire thing is 6 plus 8 plus 4. Okay, well, let's do a little bit of math, a little bit of addition. 6 times, let's see, that's 14, 15, 16, 17, 18, right? So I've got 18. 6 times 18. So I've got y squared equals 108. Square root of 108, about 10 point something, right? Square root.
10.39.
Yeah, 10.39 or 10 point, how about 10.4? Approximately equal to about 10.4, okay? Does that seem pretty easy? Okay, I think so too. So, not a big lesson, you guys, fairly easy. We do have a homework assignment, which won't take you that long. So,